gentlemen. This is section 3.1. We're talking about identifying pairs of lines and angles. So this is starting a new chapter, chapter 3. We're talking all about parallel and perpendicular lines. And we're going to take a little bit of a break from proofs for a week or so. Take a little bit of a breather, and we'll refocus on things that are more related to chapter 1 with points, lines, and planes. Starting with parallel line, which most of us should know. And what we usually do is we think of parallel lines simply as two lines that don't intersect, which is true. That's part of the definition, but we add another part in this formal geometry course. So parallel lines are two coplanar lines that do not intersect. So coplanar is kind of a key point here. They have to lie in the same plane and do not intersect. And we'll talk about why that's so important when we talk about skew lines, number 2. So parallel lines, we're used to seeing them something like this. You have two lines that apparently appear to have the same slope and will never intersect. They are coplanar, so let's call this line N and line M. They are two parallel lines. The second type of lines we need to discuss are skew lines. And skew lines are two non-coplanar lines that do not intersect. So this is where we talk about the coplanar versus non-coplanar. Coplanar means they lie in the same plane or the same flat surface. So two parallel lines are always next to each other in some type of flat surface, whereas skew lines are not. So if I were to take a look at a cube as a good example, let's say I have this line down here in the front, and we call it line R, and then the top right edge, let's call that line Q. Well, these two lines will never actually intersect. One is at the bottom going left and right, and one is at the top going forward and back. If you wanted to visualize this with an actual box or with two rulers or sticks or something like that, you will see that these two lines will never intersect. But they're not exactly parallel. And they're not parallel because they are non-coplanar. They are not on the same flat surface. One is down here and one is up here in this flat surface, the top plane and bottom plane. So they are not coplanar. And we'll talk a little bit more about skew lines in our next example. Parallel planes are two planes that are parallel. They do not intersect. And as an example of that, let's say we have these planes, R, S, and T. So all of them are parallel. S and R are parallel. R and T are parallel. And S and T are parallel. And they will never intersect. So three flat surfaces that extend forever in all directions that will never intersect. There's a nice little visual down there for you. Now, go ahead and pause this if you need to take more time to write these down. But I'm going to move on to example 1. If you would like to answer example 1 by yourself and then check your answers, go ahead and pause it and then play it when you are finished. Let's go ahead and do part A. The directions say, think of each segment in the figure as a part of a line. Which line or lines or plane or planes in the figure appear to fit the description? So let's talk about A first. A line or lines that appear parallel to CD, which is over here, and contain point A, which is over here. So we want a parallel line to CD that also contains point A. We can see that EF down here appears to be parallel. It's on the same plane on the left side of our box. And they will appear to never intersect, but it does not contain point A, so that will not satisfy our description for part A of this problem. Another example we might choose is HG. It appears to be parallel. We could draw a plane diagonally through this box, so a single flat surface that contains both those lines, but it doesn't contain point A. So our only choice is line AB. Contains point A and appears to be parallel. They are on the same flat surface, the same plane, on the top. So line AB or BA would be sufficient for the first part of our problem. All right, let's look at part B. Part B says a line or lines that are skew to line CD and contain point A. So again, we're looking at line CD and point A as a reference. So if they're skew, they're not in the same plane. So if we look at the lines that contain point A, you know that AB is parallel, so that's not skew, that will not work. If we choose AH, it contains point A and is skew. These two lines will never intersect and they are not coplanar. So we could say line AH or HA, either one. A second one we might choose would be AG. They will never intersect since AG is on the plane on the right and CD is on the plane on the left or on the top, however you look at it. They are not in the same plane. Therefore, they will never intersect in our skew line. So we could say line AG or GA. Both of those are lines that are skewed to line CD. They are non-coplanar and they will never intersect. Let's look at C. A line or lines that are perpendicular to line CD and contain point A. So again, point A is kind of the key here. And we want it to be perpendicular. Well, let's look at lines that form right angles with CD that contain point A. There's only one line that contains point A that actually intersects CD, and that is AD. And we see that AD forms a right angle. So in this case, we could say line AD or DA is perpendicular to line CD, and it also contains point A. So that satisfies the conditions for letter choice C in our problem. And finally, choice D, a plane or planes that are parallel to plane EFG and contain point A. Well, if I were to outline EFG, so E, F, and G, all three of those points are on the bottom of our cube. So that's going to be the plane that's on the bottom. We want a plane that's parallel that contains point A. Well, the only plane that never intersects that bottom plane is our top plane. So the rest of them cannot be parallel because parallel planes never intersect. So in this case, it must be the one at the top. And since it contains point A, it satisfies our description. Now remember, to name a plane, you choose any three non-collinear points. So any of these, three of these will work because none of them, three are collinear. So we can choose any three of those to satisfy this. And the order doesn't matter. So I can call a plane CAB, or ABC, or BAC, or DCB, any of those orders, because no three of those are collinear, so this will work. So plane CAB will satisfy. Two postulates that we should look at. These come up once in a while. They're useful in certain types of problems. We don't use them nearly as much as other postulates like linear pair postulate, or as theorems such as a vertical angles theorem or congruent complements theorem and things like that. So the first is the parallel postulate. This is one of the postulates that are just accepted as mathematical fact, and they are assumed to be true. These are what Euclid used in his geometry. In his book, actually, or his collection of books, it was actually called the Elements. So in the Elements, this is what he used. So if we have a line, let's say this is line L, and some point that's not on the line, there's only one line we can draw through point P that's parallel to line L. Only one possibility. Any other possibility that we will draw through that point won't be parallel. It will somehow intersect with line L at some point. So there's only one possible parallel line that we can draw. And the notation for parallel lines is you see these little arrows. If they have the same number of arrows, just like the same number of tick marks with congruence, if they have the same number of arrows, then they are parallel. So those two lines are considered to be parallel. Similarly, for the perpendicular postulate, let's say we have this line L again and point P again. There's only one possible line we can draw through P that will be perpendicular to L to form that right angle. Any other line we possibly draw will not form that right angle. There's no other possibility. So there's only one perpendicular line that we can write there. That's our perpendicular postulate, postulate 14. So let's look at an example here using those the notation we talked about with parallel and perpendicular. So let's start with letter A, where it says name a pair of parallel lines using this diagram at the right. And I'm just going to make all these lines to make life a little bit easier for today, not worrying about rays or segments or anything. Let's just assume that all of them are lines. So name a pair of parallel lines. Well, we see these two arrows here and these two arrows here. So since they have the same number of arrows, they are parallel. So I can say that line MD, and line FE are going to be parallel. So MD, the line MD, and line FE are parallel. The way we can write that is to write this little parallel symbol in between, which looks like a number 11 or two L's next to each other. That means that they are indeed parallel. And you see that in part C here, actually. So for letter choice B in this answer, Second part, name a pair of perpendicular lines. Well, I see one right angle here. So there's only one angle pair that's going to be perpendicular. Sorry about that. So there's only going to be one set of perpendicular lines, and here we have line BF that's going vertically. And line MD, again, that's horizontal. And they form that right angle, therefore they are perpendicular. And for the last one, part C, is line FE parallel, again that's parallel, to AC. So let me erase this stuff we already have in the diagram to make this a little bit more simple. So we're looking at line FE, so I'm going to go ahead and trace that. And AC. The correct answer here is no for two reasons. One, you would see the obvious, that at some point in the future they're going to cross. If I were to extend these lines continuously, they would cross at some point, somewhere around here. And the second thing is they don't have the parallel lines, the little symbols with the two triangles, like over here. So we cannot assume they are parallel if we don't see those lines. So in this case, it's going to be no. You can talk about from the picture, but more specifically, you should know that since they don't have the markings, we cannot assume this. So this is going to be no for choice C, or problem part C. Now, for these special types of angles, let's say we have two parallel lines, or two lines in general, these two lines. A line that crosses through two or more lines is a transversal. So it's a line that intersects two or more coplanar lines at different points. So here, this line intersecting two lines, one here and one here at two different points, would be our transversal. So I'll go ahead and call it T. That's our transversal. But when a transversal crosses through two lines, special types of angle pairs are formed. The first are corresponding angles. Corresponding angles are angles that are in the same position. For an example of corresponding angles, if I were to say angle 2, an angle that corresponds to angle 2 would be angle 6. Angle 2 is in the top right of these four angles, and angle 6 is in the top right of those four angles. So they are in the same or the corresponding position. So I could say angle 2 and angle 6. I wanted to look for a different pair. Let's say I said angle 4. Angle 4 is in the bottom left. So the one that's in the bottom left down here is angle 8. So angle 4 and angle 8 would be corresponding. They're in the same positions. So those are corresponding angles. The next type are alternate interior angles. Alternate interiors are on the inside of the two lines and opposite sides of the transversal. So I think alternate interior, I think opposite sides, I think of the inside of the two parallel lines. So on the inside of my two parallel lines here, or two lines in general, they don't have to be parallel, are 4, 3, 5, and 6. Those are my interiors. So ones that are on alternate sides would be 4 and 6. They're on different sides of this transversal, but they're on the interior, inside here. So angle 4 and angle 6 would be examples of alternate interior angles. So again, I would say one example would be, angle 4 and angle 6. I want to look for a second pair. I could say angles 3 and 5. Alternate sides, interior. So angle 3 and angle 5. Well, if alternate interiors are on alternate sides of the transversal inside, if I look at alternate exteriors are on the outside portions out here, and alternate sides of the transversal. That's what alternate exteriors are. Outside of the two lines, on opposite sides of the transversal. Let me scroll just a little bit here. And if you need to pause it to copy that definition down, go ahead and pause it, because I'm going to go and hide it again. So if I were looking for examples of alternate exteriors, 2 and 8, alternate sides of the transversal on the outside, so angle 2 and angle 8. I wanted a second example, 1 and 7, alternate sides on the outside or the exterior of those two lines cut by that transversal. And the last one, consecutive interiors, also known as same-side interiors. They are inside the two lines, but on the same side of the transversal. So when I see consecutive, I also think same side. Different textbooks call them consecutive. Different textbooks call them same side. I personally prefer same side, but consecutive is what our textbook uses, so I put it up here just so that you're aware of it. So on the same side of the transversal, on the interior of our two lines. So interior, inside here, on the same side. So as an example for those, I'm going to go ahead and hide this again. Interiors, I could look at 6 and 3. They're on the inside, but on the same side of our transversal. So I could say angle 3 and angle 6, or as you probably guessed, angle 4 and angle 5. Same side, interior. Also known as consecutive interior. So let's do an example involving some of these to kind of solidify your understanding here. Identify all pairs of angles of a given type, corresponding, alternate interior, alternate exterior, and consecutive interior. Well, let's start with A. Again, if you want to attempt this on your own, go ahead and pause it, and then play it when you're ready to see the answers. So let's start with corresponding. Well, corresponding are in the same position. So here's my transversal, and these are my angle pairs that I'm looking at. Well, angle 1 and angle 5 are corresponding. They're both in the top left. So angle 1 and angle 5. I know that angle 2 and angle 6 are both in the top right, so I can say angle 2 and angle 6. Angle 3 and angle 7 in the bottom left. And angle 4 and angle 8 in the bottom right. Those are all of my corresponding angles. For my alternate interiors, I'm looking just on the inside, just in here, in this area. So just dealing with these 4 angles. Well, alternate interiors are on alternate sides of my transversal, so on the top and on the bottom. So angle 2 and angle 7 would be alternate interiors. And then angle 4 and angle 5 would be alternate interiors. For part C, we're going to look at alternate exteriors. Oh, that's kind of neat. That was completely by mistake. So exterior, we're dealing with the outer portions out here. So 1, 3, 6, and 8. So I know that angle 1 and angle 8 are on alternate sides, top and bottom. So angle 1 and angle 8. And angle 3 and angle 6. Those are my alternate exteriors. And for part D, to finish it up, consecutive interiors, they're on the inside, so because they're the interior angles, and they're consecutive, so the same side of our our transversal. So same side interiors, 4 and 7, and 2 and 5. Angle 4 and angle 7 are on the same side of the transversal and on the interior, and then angle 2 and angle 5. Same side of the transversal on the top, and they're on the inside of our two lines. All right, so if we want to just classify these, let's sum these up as our last 3 examples. So for number 3, 1 and 5, they're both in the top left position, therefore they are going to be corresponding angles. For number 4, they're not corresponding. One's in the kind of the top left here, one's kind of in the bottom right there, so that's, top right and bottom left. So that's not going to be corresponding. They're on the exterior, they're not on the inside, so they're alternate sides on the outside, the exterior, so they're alternate exterior angles. And for number 5, well, they're not corresponding because they're on different sides, so they can't be corresponding. They're not on the exterior, so they're not alternate exterior. So they're either alternate interior or consecutive interior because they're on the inside. And I'm going to go ahead and classify them as alternate interior because they're on different sides of our transversal. So that's going to be alternate interior angles. That concludes the basics of section 3.1. We'll be discussing this in class and doing an assignment in class. So I hope this video is helpful. Please rewind as needed and enjoy the rest of your weekend.